Hello everyone, welcome to another video. Today I'm going to be working on this PlayStation 5. This has been sent in by a customer and it's got no power. But it does come with a little bit of a twist. I can't power this on and test it because according to the little note that's on it and the note that's inside the box, it says do not power on missing MOSFET. So I think the customer's tried to power it on and made a mistake by doing that. I don't think that would hurt the console too much, to be honest, but yeah. We can't power this on because we do know there's some missing components and stuff like that, but we'll obviously get to that as we get inside it. But with that being said, my name's Hakko, I'm an electronics technician. I do mainly work on games consoles, but I do work on other stuff as well. So if you enjoy that kind of thing and you want to see more, be sure to hit the subscribe button and turn on the bell notifications. That way you won't miss any future videos. If you want to organise a repair, you can get in touch with me at thecoded.repair. And if you need parts and supplies for the PlayStation 5, Xbox Series X or any other games console, you can buy those on my online store at consolefix.shop. But I'm going to get into this repair, I'm going to take this apart, but first I'm going to tell you all about today's sponsor, PCB. Today's video is sponsored by PCB. Whether you've got a simple project that requires a quick mod board or you want to launch your own products to the world, PCB can help. With fantastic pricing on multi-layer PCBs, flex ribbons, 3D printing and even laser cutting solutions, you're sure to find everything you'll need all in one place. Custom PCBs start from just $5 for a 1 to 2 layer board with a fast 24-hour build time and free shipping on orders over $30. PCB also offer aluminium PCBs starting at just $120 per square meter. Check out what PCB have to offer by clicking on the top link in the video description or in the top pinned comment and get your project started today. Thanks again to PCB for sponsoring the channel. Now let's get back to the video. So, like I said, this console, it's not able to be powered on until I at least know what we're dealing with, what we're up against. I don't know what MOSFET is missing. There is one inside a ESD packet hanging in the breeze just here. But I don't know what's actually missing. I haven't looked at that MOSFET yet, so I'm not really concerned too much about that. That's the wrong screw. And one funny thing is, the note says feel free to roast me about my work. Like, this is a guy who's just trying to fix things. Like, I'm not going to roast him. If he was a professional, you know, a repair shop, then yeah, maybe. But not just a normal guy trying to fix stuff. But yeah, we'll see what the situation is, and I'll see if I can roast him in good conscience. But yeah, let's just have a look. So I'm going to get rid of these screws here. We do have the wrong screw there, so I'm going to have to take care of that in a second. But I'll get this thing apart. I'll fast forward through this bit because it's boring and no one wants to see it. Okie dokie, so I think I remember this where there was quite a bit of damage on this. You know, there's a few chips, I think. So I'm seeing one here, and it's just refreshed my memory on the conversation that I had with the customer, and I think that this has got some blown chips around the other side, and more specifically around things like USB-C and stuff like that. And this is going to come out to not so much a really expensive repair, but more expensive than I would normally charge, right? And the reason for that is mainly because of how many chips I'm going to have to replace on this. I think this is going to be a fairly big job in terms of the amount of chips that need replacing. So yeah, this is why it can't be turned on. I think I'm probably advised for it to not be turned on and stuff. You know, just given the fact that we've got so much damage. But yeah, let's pop this under the microscope and we'll start to take a look around this area here and then the area on the other side. We do have this missing MOSFET here on the 12-volt line. I don't think that's going to hurt too much in terms of powering the console on, but yeah, these chips here, these blown chips here, they are going to cause an issue. So yeah, let's have a look at that first. Yeah, so as you can see, we've got a fair bit of damage. Well, I mean, you can see one chip at the minute, but this chip here, for example, this goes to some of the USB lines. I think this is the power management chip for USB type A, and that's got a little bit of a blowhole in it. On top of that, we've also got some... Oh, actually, no, that's not. That's fine. That looks like it's just flux. So that one there looks like it's just flux. So from the pictures it looked like this one was blown as well, so I obviously added that into the quote. So I added like a little bit of money on for that. So if that works, then obviously we don't need to replace that. This is the Type C USB chip. So you know the Type C port at the front, that's what powers that. This one I believe powers Type A. So yeah, we got that, and then we've also got some 5-volt MOSFETs here for the front USB as well. We've got the matching MOSFETs at the top of the board just here, and these ones are for the rear ports, but these ones down here are for the other one. I mean, this board is a little bit of a mess, but it's not as bad as I initially thought it would be. So first thing I'm going to do is get these removed, and I'm going to start with this one just so I can try and inspect what's going on with this one and see what kind of damage we're dealing with here. One thing I'm going to point out as well, this chip is very burnt, right? So it's going to need a fair bit of heat. So I'm using 480 degrees Celsius on this. I'm dropping my airflow down to 20%, but I am using pretty high heat on this because it's burnt and I want to lift it off as safely as possible, with as little traces being pulled up as possible. We've definitely got a damaged trace there, so we're going to need some QFN trace repair. Right, so even though this is loose, I'm giving it a second just to try and reduce the amount of damage I cause. But that's that one. Let's go ahead and remove this one as well. So it looks like we've had a short on the 5-volt line. There we are, so that's that one sorted. Or removed at least. We've got a missing MOSFET here, which, like I said, that shouldn't cause too much issue. What is this gunk here? So I'm seeing this in a few places. No, that's not a gunk. That's a burn mark on that capacitor. Oh yeah, that's definitely burnt. These capacitors cost pennies. One of these has took a hit. They're all coming off. There we are. So there's all of those removed. So what I'm going to do now is just clean up this side of the board. I'm just going to flood it in IPA. And I'm just going to clean up this side of the board here, just to get rid of any flux and stuff, just so I can start fresh here. It's a little bit warm, but we do want it warm because that helps to clean the flux up. So if I clean up, I can see what we're dealing with. But it looks like it's all just 5-volt shorts, right? It doesn't look like we've really got many other issues, apart from the missing components. But I think what's happened here is the customer's probably looked at it, he's removed one of the MOSFETs to, you know, try and isolate a short. He did see these other shorts, but he probably thought because of the trace damage and stuff, it's probably just a little bit out of his league, which is fine, you know your limits and stuff like that. But yeah, I think that's probably what's happened here, but that's fine. I'm gonna just get all of this cleaned up, give us a nice blank canvas to work with. So I think the error code on this was 8081001 on UART, which is just a general power failure on 5-volt. Well, it's just a general power failure. You know, some component somewhere has blown. It can be a bunch of different things. But I think when he connected it up to UART, that's what was coming up. So, yeah, we don't really need to connect it up to UART. I'm just going to clean up. And what I'm going to do is I'm going to get rid of this component from this side as well. Alright, we've got some burnt traces here as well. Yeah, that's taking a bit of a hit. So I'd say this side is probably the worst of it, to be honest. So there is a bench fee on this, by the way, just given the amount of work that's going to be involved to even try and get it to a point where it might turn on. So there is a bench fee involved on this of £30 if I can't fix it, just to cover my time, electricity costs and all of that stuff. Alright, so that's clean enough now to see what we're dealing with. We do have a little bit of a wonky transistor there, but I'll deal with that later. Yeah, that's taken a pretty big hit on this side, hasn't it? Wow. So chances are this is short to ground. So this line here, this isn't meant to be ground, but it's probably short to ground. If I just grab my multimeter and put that into continuity mode, that'll tell me if we've got a short here. And continuity mode, it's going to lie to you sometimes, by the way. If there's anything under 50 ohms, most multimeters will beep. So always actually look at your multimeter, don't just listen for the beep. I'm in continuity mode here. So if I just check this cap, which is on the same line, yep, that is indeed short to ground. And the chances are it's going to be short to ground because of this area here. So what tends to happen is when you get a short of this magnitude, it will basically burn through a layer of the board. And for example, this here is ground, and there's also going to be a ground layer in between this layer and the next layer on the board. And what tends to happen is when it burns a layer through, a layer on the board, it fuses those layers together. So that right there is going to be ground, right? And obviously that's not great at all to have that. So we're going to need to do a little bit of scraping on this just to get rid of that short, because it's basically fused the layers together. So we're going to need to use the grinding pen. And you just have to tighten that up because it's not going to grind properly if it's loose. I'm not bothered about these caps and stuff around here, I can always replace those. So I'm just going to clean this up. It might take a little while. And I'm just going to grind away at this substrate and try and clear this short. It's definitely going to be an internal short because of the layers being fused together. But one thing I am going to do is I'm going to peel back this top layer a little bit here, like this, and just completely isolate that from any burnt part of the PCB. It doesn't really matter how much of this I take back. It's all part of the same pad. I'm just going to peel it back a little bit and just move that copper out the way so as it can't short out. There we go. That should be enough. So let's get rid of that. Let's just clean this away. And I'm just going to whoops, I dropped my knife. I'm just going to trim it back with the blade. Make sure it's nice and clean. There we are. Good. I'm going to get rid of... Actually, no, let's see if it's still short. I was going to get rid of that cap, but I'll get rid of it in a second. We are still short. We have a 19 ohm short here. We're going to need to figure out why that's short, because it doesn't look like these layers are fused together anymore. What I will do is if I just scrape this back a bit more, like so. Still 19 ohms short, so let's get rid of these caps here. So if we look on this line, what have we got on this line? We've got a bunch of resistors, they're not going to be causing the short. We've got this cap here, that could be causing it. These two caps could be causing it. I'm going to ping that cap off. And yes, I know, I shouldn't be pinging it off with the tweezers. Doesn't matter, this trace is knackered anyway. 19 ohms short, still. Okay, let's try this one. Ping. Don't try this at home, folks. There it is. Open line. Good stuff. So this line now. Oh, hang on. No, it's still short. Huh. It lied to me. Alright, well, we need to find out why. So I'm going to use the thermal camera because it's easier. Okay, so what I'm going to do here is I'm going to inject some voltage into this, and basically what that's going to do is it's going to force power to go through the board. And when you think about it, the easiest way to explain this for voltage injection, electricity is very, very lazy. Okay, so it's always going to want to try and flow through the path with the lowest resistance, whether that be, you know, through a component, or whether that be straight to ground because of a short or whatever. It's always going to take the path with the least resistance, and if there's no resistance, then it's basically going to be able to draw as much current as it wants, right? Or as much current as, you know, you allow it to draw. So if it's drawing a load of current because one of the components are short, so for example a capacitor is short somewhere, that capacitor is going to get hot because it's pushing a load of current through that and then sinking it to ground, but it's still flowing through the component, right? So it's going to get hot, and then the thermal camera should tell us where the short is. So if I just inject 2 volts into this, I'm not going to inject 1 because 1 volt probably won't be enough, given that we've got a 19 ohm short. So 2 volts, and even that isn't enough. We're only getting 0.8 amps, 0.08 amps. I'm going to have to go up a bit more, and even at 5 volts we've only got 118 milliamps of current draw here, and that's dropping as well. So it looks like it might be trying to burn it out. Yeah, it's trying to burn it out. We're only getting 100 milliamps at 5 volts. So what I'm going to do, I'm going to plug in the thermal camera, and I'm just going to have to increase voltage up to 12 volts by the look of it, just because of the short that it's got. So I'm going to go to this camera, and I'm going to take my thermal camera. This is the Infrared P2 Pro. Very good camera, not sponsored, although I did receive it for free, but that was like 2 years ago. So yeah, very, very good camera, absolutely amazing, I highly recommend it. There's an affiliate link in the video description, and that does obviously help out my channel when you use my links, because I do get a little bit of a kickback off them. But I'm going to load up the TC View software, and that should load up on the screen now. Wow, that's big. Ha! Okay, so we've got a thermal camera view here. So if we take a look here, we can see the board. Hello. I'm going to inject voltage into this. We've got 100 milliamps. Nothing getting warm at the moment. So I'm really just looking for heat spots in this corner more than anything, because there's not really much to see, right? So yeah, I'm just looking for heat spots here really in this corner. That was just a reflection. Okay, I'm going to increase to, I'm going to put 7 or 8 volts through it. 8 volts will do, why not? So I'll put 8 volts through it. And yeah, this is definitely a substrate issue, this is, but it could be on the other side of the board, because I got a spike of, you know, 600 milliamps for a millisecond, and then it jumped down to 160. So yeah, okay, this is probably a substrate short. I'm just going to go straight to 12 volts. This is a 12 volt line. 800 milliamps of current draw. Oh. Okay, it's trying to power on these MOSFETs. Yeah, so I'm providing it with 12 volts straight through the MOSFETs, and it's trying to power them on, but it's not powering them all on. Look, something's not right here. So you can see the gaps there. Like the MOSFETs are not powering on, the ones that are not receiving power, like it's pulling them down. Let's pop on the other side of the board. Let's have a look from this side. We could have a short around here. Oh wow, yeah, you can see a bit more prominently that side, can't you? So the PWM's powering on. The MOSFETs are... Oh! Just took that one out. Okay, that's why we've got a short. That's just let out magic smoke on this one as well. That explains it. Yeah, it's just let out magic smoke on that one as well. All right. So this is the other 5-volt MOSFET on the USB data, on the USB lines, the USB rails. And it's just let out magic smoke on that one there as well. That would probably explain the short. Let's get rid of that one. I'm wondering if we've got broken USB ports. Oh wow, look at that. Tried to weld itself to the board, didn't it? You wasn't getting away with that, was ya? Okay. Right, I'm going to have another look at this then now. So you'll just have to take my word for this. Let's have a look at what kind of current's being drawn now. Still 700 milliamps. That's just not making much sense. I don't think it needs this one to power on, but that being said, oh, yeah, that's a bit. I mean, those lines are shorted together for a start because they're damaged. That's a bit rough. I don't know where this line goes, but that is rough. This is not good at all on this line. I've had to come all the way back to the edge of the wire there on that one. Let's just grind a little bit of this away because it can't stay like that. That goes deep. That goes deep. That goes through multiple layers. I can already tell that just by looking. Yeah, it's gone through quite a few layers, that has. Oh, that's not good. Let's just see what we can do about separating these. I'm trying to tell if they're actually separated or not. Right, so let's have a look here then. What's the situation with this line? Is this line short to ground? Yeah. They all are. Including that one. Yeah, I don't know if that's meant to be ground. I can check. I can check on another board. But given where that's burnt, I don't think it's going to be ground. You have to excuse the state of this board. This one has seen much better days. So this is the area in question, and yeah, this board has seen better days. I am going to clean it up a little bit because, well, this board is absolutely rotten. So I'm going to get this chip off here. Alright, there we are. So, okay, I can see a little bit clearer now. So that line that was blown, the two wires that I saw, you know, the two exposed wires, they are part of the same line. They are part of the same line, but the question is, what are they to? Right? Are they ground, or are they not meant to be short? Because if they're not meant to be short, then we have a problem. They are not meant to be short. We've got open line there. So that is not meant to be ground at all. Which one is ground? That one next to it. How about this one next to it? No. Okay, so now we know where this is going to be fused together. So if we look at this here now, we know that this one is connected to ground, right? This bottom pin here. That pin's connected to ground, we know that. So chances are this is fused together because we've got a ground right next to this line here. So this wire and this wire, they are not ground. They're not meant to be ground, but they are connected to ground at the minute. So it's either going to be this here, which I can dig back a little bit, or it's going to be this here. One of the two. There we are. That's what I wanted to do. Just, it's ground. I don't care about it, right? Or not enough to the point where I'm going to be, you know, spending forever trying to peel it away nicely. Just get rid of it. It's just a ground point. So break that away and get rid of that. And now I can clean it up and reevaluate it. There we are. Right, now I can see a bit better. So this line here, it looks like this part here is probably ground because this is an inner layer, right? And this trace, yeah, that's fusing to it, isn't it? I'm going to dig around that, make sure I separate that line. Just like that. Let's check it again now. Are we still short to ground? Damn it. So all of this here is ground as well. So I'm going to have to grind away a little bit more. And just hope that we can get this short cleared. Is it there? I'm basically drilling through the board here to try and isolate this line. I mean, at the very worst, we're probably not going to have any 5 volt for USB on the front lines, but if that can't be helped, that can't be helped. I could always tap into 5 volt from elsewhere, you know, to give it power. Right, so let's just dig through that. Okay, what about now? Damn it! Right, is it because of this one then? Still short. Right, so I'm just going to try and get rid of this wire completely. Or at least from the top layer. Yeah, okay, now I'm seeing it. Yeah, I'm seeing the burn marks here now. Yeah. So can you see the black substrate there where it's burnt? This has gone probably all the way through the board, this short, considering it's taken out other components as well, right? It's probably gone all the way through the board. Alright, what about now? Haha! Short gone. Look at this. Look at this. No short. Yeah, short gone. Yeah, baby. That's what I'm talking about. The short is gone. Alright, so yeah, this layer here is ground. Or at least it appears to be. and because of the burnt substrate on the wire, or around this wire here, that was causing this wire to short out to ground. Like, it was all just fused together, and obviously that's not good. So what I'm going to need to do, once I've cleaned this up here, is I'm going to need to tap a wire onto these wires, and then I'm going to need to basically protect it all. So I'm going to need to try and protect it without, well, I mean, realistically I need to find out where this where this wire goes to on the other side of the board. I'm assuming it goes to the other side of the board, considering this wire is so deep. So you've got a couple of types of wire. You've got a through hole wire where it'll go all the way through the board, and then you've got another wire where it'll just go to another layer. And this one looks like it's going all the way through the board, right? So I mean, we're pretty deep in there now. That's fairly deep inside the board. We're almost through to the other side. So I'm gonna just try and I mean, I'm not really seeing it. I think it goes to here. So we've got some components just here with a bunch of wires. I'm thinking it goes to there. Maybe. Let's just have a look at this area here. Are we still short on this area? Ah, we still have 18 ohms. Damn. Yeah, we still have 18 ohms on that. We've still got more shorts. So what's the situation when I give it 12 volts into the power supply connector? Yeah, we still get that 700 ohm current draw. Sorry, 700 milliamp current draw. So what's the story in Balamura? Is it going to give me any signs of heat now? Yeah. It's really only the MOSFET's getting warm. But then again, I mean, has it taken out a bunch of those FETs? Surely not, right? So we've got a bunch of FETs here. I'm not seeing any damage on these MOSFETs at all. Hello, hang on, what's this? Yes, we have a MOSFET blown there. Is that a blowhole? Yay or nay? Yay. Yes, it is. Alright. Yeah. That's a blowhole. Okay, there we go. So that's removed. Yeah, that was a little bit of a blowhole in that one. I'm going to need to remove this paste from around here. Alright, so I've got a capacitor which has come sort of loose from that, but never mind. Not seeing any more blowholes in these MOSFETs here, so yeah, it's possible that that was all that was wrong with that. Let's just have a look around this area again and just see, do we still have a short on here? We do still have a short, 16 ohms still. Well, that's annoying. Let's just have a look and see what kind of power gets drawn. So I'll just inject 12 volts into here again. So just into the power connector. I'm just on the opposite side of the board, that's all. Still that same 700 milliamps of current draw. Oh, hang on. No, never mind, I just lost connection. So I'm injecting voltage there. And obviously my ground is connected down here. No, we still get the same 700 milliamps of current draw, and yeah. How long have I been recording? An hour. Well, I think, given just how many shorts there are on this board, so we've got burn marks in the PCB here, so we could still have substrate damage there. We've got a blown MOSFET there. We could have internal damage on the substrate on that part. We've got some major damage here on 5 volt for USB. So I don't think this is worth fixing. I'm going to be honest, I really just do not think this is going to be worth fixing, just given the amount of damage we got. So I basically had to drill through the board here just to try and relieve that short, but I just cannot see where the other short is coming from. I could pull every single MOSFET off the board, but I don't think it's going to be worth it. I'm going to speak to the customer, see what the customer wants me to do, but I don't think it's worth it. I think it's going to cost too much money, and it's going to be cheaper just to find the customer a new board. Yeah, I think it is what it is with this, so I'm going to leave it there. I'm going to call this one a no fix, unfortunately. So yeah, thank you very much for watching. I hope you enjoyed it. I'm a little bit annoyed, not at the customer, just not being able to find the fault. I mean, I know roughly where the fault is. There's a 19 ohm short on a 12 volt line, but I can't see where that 19 ohm short is going to be, not without drilling through the rest of the board. We've already got one drill hole in the board, and it's probably not going to work after just that one drill hole anyway, so yeah. Never mind. I will probably try and source the customer a new board, see what the customer wants to do and stuff, but yeah, I'm probably going to be calling it a no fix on this one. So thank you very much for watching. I hope you enjoyed it. Let me know what you think down in the comments down below. Have you ever seen one this bad? Because I don't think I have. I think this is probably the worst I've seen, because we've got multiple faults on multiple rails with multiple blown components and multiple areas where there's substrate damage and, you know, layer fusion and stuff like that. So yeah, I just don't think it's worth continuing. But thank you very much for watching. Don't forget to comment and subscribe, and yeah, turn on the bell notifications and all of that good stuff. You can buy parts on my online store, and I'll see you all in the next video. Take care, everyone. I'll see you later. Bye for now.